Screws, a modular framework for reasoning with revisions. Large language models, LLMs, can improve their accuracy on various tasks through iteratively refining and revising their output based on feedback. We observe that these revisions can introduce errors, in which case it is better to roll back to a previous result. Further, revisions are typically homogeneous. They use the same reasoning method that produced the initial answer, which may not correct errors. To enable exploration in this space, we present Screws, a modular framework for reasoning with revisions. It is comprised of three main modules: sampling, conditional resampling, and selection, each consisting of submodules that can be hand-selected per task. We show that Screws not only unifies several previous approaches under a common framework, but also reveals several novel strategies for identifying improved reasoning chains. We evaluate our framework with state-of-the-art LLMs, ChatGPT and GPT-4, on a diverse set of reasoning tasks and uncover useful new reasoning strategies for each: arithmetic word problems, multi-hop question answering, and code debugging. Heterogeneous revision strategies prove to be important, as does selection between original and revised candidates. Small-scale proxies for large-scale transformer training instabilities. Teams that have trained large transformer-based models have reported training instabilities at large scale that did not appear when training with the same hyperparameters at smaller scales. Although the causes of such instabilities are of scientific interest, the amount of resources required to reproduce them has made investigation difficult. In this work, we seek ways to reproduce and study training stability and instability at smaller scales. First, we focus on two sources of training instability described in previous work: the growth of logits in attention layers, Degani et al., 2023, and divergence of the output logits from the log probabilities, Taesiri et al., 2022. By measuring the relationship between learning rate and loss across scales, we show that these instabilities also appear in small models when training at high learning rates, and that mitigations previously employed at large scales are equally effective in this regime. This prompts us to investigate the extent to which other known optimizer and model interventions influence the sensitivity of the final loss to changes in the learning rate. To this end, we study methods such as warm-up, weight decay, and the Mu-Param, Yang et al., 2022, and combine techniques to train small models that achieve similar losses across orders of magnitude of learning rate variation. Finally, to conclude our exploration, we study two cases where instabilities can be predicted before they emerge by examining the scaling behavior of model activation and gradient norms. DeepSpeed-VisualChat, multi-round multi-image interleave chat via multimodal causal attention. Most of the existing multimodal models, hindered by their incapacity to adeptly manage interleaved image and text inputs in multi-image, multi-round dialogues, face substantial constraints in resource allocation for training and data accessibility, impacting their adaptability and scalability across varied interaction realms. To address this, we present the DeepSpeed-VisualChat framework, designed to optimize large language models, LLMs, by incorporating multimodal capabilities, with a focus on enhancing the proficiency of large vision and language models in handling interleaved inputs. Our framework is notable for 1. Its open-source support for multi-round and multi-image dialogues, 2. Introducing an innovative multimodal causal attention mechanism, and 3. Utilizing data blending techniques on existing datasets to assure seamless interactions in multi-round multi-image conversations. Compared to existing frameworks, DeepSpeed-VisualChat shows superior scalability up to 70 billion parameter language model size, representing a significant advancement in multimodal language models, and setting a solid foundation for future explorations. Vid Chapters 7. Video chapters at scale. Segmenting long videos into chapters enables users to quickly navigate to the information of their interest. This important topic has been understudied due to the lack of publicly released data sets. To address this issue, we present VidChapters 7M, a dataset of 817K user-chaptered videos, including 7M chapters in total. VidChapters 7M is automatically created from videos online in a scalable manner by scraping user-annotated chapters and hence without any additional manual annotation. We introduce the following 3 tasks based on this data. First, the video chapter generation task consists of temporarily segmenting the video and generating a chapter title for each segment. To further dissect the problem, we also define 2 variants of this task. Video chapter generation given ground truth boundaries, which requires generating a chapter title given an annotated video segment, and video chapter grounding, which requires temporarily localizing a chapter given its annotated title. We benchmark both simple baselines and state-of-the-art video language models for these 3 tasks. We also show that pre-training on VidChapters 7M transfers well to dense video captioning tasks in both zero-shot and fine-tuning settings, largely improving the state-of-the-art on the UCook2 and ViTT benchmarks. Finally, our experiments reveal that downstream performance scales well with the size of the pre-training dataset. Our dataset code and models are publicly available at the project's website. Calibrating LLM-Based Evaluator. Recent advancements in large language models, LLMs, on language modeling and emergent capabilities make them a promising reference-free evaluator of natural language generation quality and a competent alternative to human evaluation. However, hindered by the closed source or high computational demand to host and tune, there is a lack of practice to further calibrate an off-the-shelf LLM-based evaluator towards better human alignment. In this work, we propose Auto-Calibrate, a multi-stage, gradient-free approach to automatically calibrate and align an LLM-based evaluator toward human preference. Instead of explicitly modeling human preferences, we first implicitly encompass them within a set of human labels. Then, an initial set of scoring criteria is drafted by the language model itself, leveraging in-context learning on different few-shot examples. To further calibrate this set of criteria, we select the best performers and redraft them with self-refinement. Our experiments on multiple text quality evaluation datasets illustrate a significant improvement in correlation with expert evaluation through calibration. Our comprehensive qualitative analysis conveys insightful intuitions and observations on the essence of effective scoring criteria. Exploring large language models' cognitive moral development through defining issues test. The development of large language models has instilled widespread interest among the researchers to understand their inherent reasoning and problem-solving capabilities. Despite good amount of research going on to elucidate these capabilities, there is still an appreciable gap in understanding moral development and judgments of these models. The current approaches of evaluating the ethical reasoning abilities of these models as a classification task pose numerous inaccuracies because of oversimplification. In this study, we built a psychological connection by bridging 2 disparate fields, human psychology and AI. We proposed an effective evaluation framework which can help to delineate the model's ethical reasoning ability in terms of moral consistency and Kohlberg's moral development stages with the help of psychometric assessment tool-defining issues test.